about the atom is that atoms make up, they're indivisible and they make up everything. So all matter, or all elements, are made up of this simple particle called the atom. So it's kind of repeating the definition when we take a look at Dalton was a scientist that tried to put a lot of these ideas together, and these ideas says that one thing we know is everything's made up of these things called atoms. So all matter is made up of atoms. This is Dalton's atomic theory. This is number one. Pretty easy concept. Okay, so if somebody asks you what's the main thought or idea behind Dalton's atomic theory, what he's saying is that there's these particles that have the same characteristics of the element, and that those atoms make up all of what we call matter. Okay, that hasn't been known of for all time. It's just they have to come up with information that kind of concludes that that's the case. So these are kind of conclusions. All four of these statements are conclusions about atoms and how they behave and what they're like. So we're just giving some information about atoms, what they're like, and some of those characteristics. The second thing is that all atoms are similar for the same element. So if we take a look at an element of aluminum, we would say that all those atoms that make up aluminum are similar. Now, in the other textbook, it said that it was a little different, but what it said is that all atoms are identical for the same element. Is that the case? Are all atoms identical for a particular element? And you would say what? No. What's different in them? What's different? You should know. Their mass. Their mass is different. So when it says they're similar, you better not say that they're the same mass, because they're not. They are similar in their physical and chemical characteristics, but they're not the same when it comes to their mass. So at the end I put this thing I called isotope. Okay? At the end there I put isotope. And what that means is that they are not all identical. They're not all identical. Okay. So we all know that matter can be an element or it can be a compound. And compounds are made of elements. So the third thing he says, these atoms, they'll tend to get together, and when they get together, they'll form a compound. Well, they'll form a compound in a particular way. Okay? So they'll form a compound in a particular way when we take a look at it.
Let's say with set ratios.
Set ratios. Okay, so they're going to say, atoms will, when they combine, they will get together, and they'll always go together in a set pattern. And that pattern's always going to be the same. All right? So let me give you a little information about that. You don't have to write this down right away. So, for example, I'm going to put, I've got 1 gram of hydrogen to 8 grams of oxygen. All right? And so that is the ratio by mass for H2O. So when they looked at H2O, they split it apart. And when they split it apart, they always came up with this ratio that when they broke it down in the simplest ratio was 1 gram of hydrogen to 8 grams of oxygen. So when they looked at it, they always came up with that ratio. And it was a set ratio by mass. So you can say, well, how come it's not 1 hydrogen and 8 oxygens? Well, what do you know about oxygen's weight? It's 16 grams that it's going to have. Its average atomic weight is 16 grams, where hydrogen's 1. Okay. So this doesn't tell you how many you have of each, but it gives you a way to know that it goes together in a set ratio. So if I had 2 grams of hydrogen, then how many grams would we have of oxygen? 16. Because the ratio still has to be 1 to 8. Okay? If I have, for example, 0.2 grams of hydrogen, you could tell me how many grams of oxygen I would have. How many would I have? 1.6. Right? Because the ratio is always going to stay the same. So when they did these experiments, Le Chatelier or Lavoisier came up with, said, hey, they're always coming up the same. So what we know, what I can deduce from that, is that atoms are going to go together in a set ratio. And then later on they found the ratio was 2 to 1. It was always 2 to 1. We could do the same for like CO2. CO2. What they did is CO2 would be 12 grams to 32 grams. So if I give you 36 grams of carbon, how many grams of oxygen would I have? So if it's a 12 to 32 ratio, I have 36 grams of carbon, how many grams of oxygen would I have? 96. Okay, so all they are ratios. You guys do a really good job with ratios and knowing how to do those. But it always comes up to be that. If it was 6 grams of carbon, how much oxygen would I have? 16, right? So they figured out it was all the same. I mean, and he got that information from looking and these are basically arguments they make, conclusions about the atom. And then the last one, you know what? They don't stay in those set ratios when we do a chemical reaction. So they won't stay that way forever. They can be taken apart. They can be reassembled and combined into a new form. And when they do that, then we know we get a different substance or a different compound. Yep.
What is RX?
RX is a short hand that I use for reaction. So chemical reactions, what do they, we've already seen chemical reactions. We know that chemical reactions give off heat, light. They'll change the color of the substance because the substance no longer has the same outside appearance. It's changed into something different with a different appearance. We know that bubbles and gases will form, which means it's a new substance that wasn't there before. And so this process of taking these atoms apart is called a chemical reaction. And when they're reassembled into forming something new and different that has different characteristics, well, that's what he's saying atoms will do. They'll go through that process of changing around. So here's one in biology that you guys have seen a rearrangement for. And here's the rearrangement for in biology. So farmers in Nebraska depend upon this right here. Don't they? called photosynthesis. CO2 brought in by the plant. Now the plant needs more to do. It needs fertilizer in which to grow to bring the other ingredients in and those type of things. But that's what happens. So CO2 is important in the process of making glucose. So what have I done? I've taken the carbon and I've put it with the hydrogen and oxygen in a different way. Okay? I've taken off the oxygen and just made it by itself. So it's just a separation and rearrangement in which to form a new compound. And we know that this gives off energy. When we eat that, we get energy out. And then with the whole process goes back in the other direction. And we go through cell respiration, and when we eat something, we're going to give out two byproducts, carbon dioxide and water. Is what we're going to give off. Okay. I was going to give you guys a quiz before you left, and it's just an exit slip. So we're going to treat it like a bell ringer tomorrow. And when you come in, it's just going to be over isotopes. It's just going to be over. It doesn't count against you. The average grade first period, I got through grading them, was around an 85%. So about 8.5 out of 10 students were getting them right. So I feel pretty confident you guys will do a good job on it too. And so we'll do that right away tomorrow. Guys, I'm putting 2 videos on Google Classroom. They're going to be about 5 minutes each, and they're going to cover some individuals and some experiments that were done in which to find these different parts of the atom. Okay? And you'll need to watch those before Thursday so that we can discuss those on Thursday. Okay? All right.